Hello to everyone and welcome to our cloud coaching session today. So today is a special day. It's all about containerization. I'm Violeta. I have with me Alberto, who will be your presenter and your guided tour for the Jenkins meets Oracle Container Engine for Kubernetes, aka OKE session. We have also Marta in the call here to help you with any questions you might have during the session. Keep in mind there is also going to be a dedicated Q&A session at the end of this call. We have also Tom, and we are here to help you and to guide you during this live webinar. That was all from my side. Alberto, the floor is yours.
Thank you, Violeta.
You're welcome.
Let me share. Yeah, let me share the slide. Okay, so let's start sharing the screen and let's start with the presentation.
All good. We can see your screen very well.
Good. Thank you, Violeta, again. I'm Alberto from the Cloud Native Specialist team, and today I want to explore with you the world of Jenkins and Kubernetes. So why Jenkins? Well, first of all, Jenkins is still used across many customers in the world. So it's still a CICD framework, very used, and it is open source. And second, because it is a good learning experience, we will start seeing common DevOps problems and how to implement and also deploy Jenkins using cloud-native technologies like Helm, GitOps, configuration as code, pipeline as code, and stateless Kubernetes agent. So it's more of a journey, and it serves as a good example of how to improve an existing architecture and with cloud-native technologies. So the agenda for today is the following: that we will see a DevOps scenario, what is DevOps, and also who is a DevOps engineer, and what are the problems related with using Jenkins. So we will see a list of problems. We'll have a list of problems to solve in these sessions. Then I will tell you about Jenkins plugins. That is, Jenkins is mostly made of plugins. And I will point out to a set of useful Jenkins plugins to modernize Jenkins with a cloud-native approach. Then we'll put all together, and I will provision Jenkins on Oracle Kubernetes Engine, so the managed Kubernetes on Oracle Cloud. And lastly, I will talk about how to optimize the costs. So how can we optimize the resources that Jenkins consumes on Kubernetes? The time is 50 minutes, so let's start. So in this first step, I want to explore what are the DevOps challenges through a real-world scenario. We will be, for one session, the DevOps engineer, and we will see the point of view of a DevOps engineer. But first of all, what is a DevOps engineer? What is DevOps? So when we talk about DevOps, it's not about the tools. There are even tools for DevOps, but DevOps is more a way of working that enforces collaboration through different through the whole organization and helps to achieve continuous delivery. Different tools contribute to different steps in the life cycle. So in DevOps, we first plan a release, we code it, we build it, test it, and release and deploy and operate and monitor. These are the stages of DevOps. And the circle build, test, release, and deploy, because in this session, we will see as a tool Jenkins, and Jenkins is used to build, test, release, and deploy. And if you see a DevOps engineer, the DevOps engineer is mainly an IT generalist. So if you look up at the formal definition of DevOps engineer, for me, it's like a wizard. That's why I put here the wizard icon, because it has to know almost everything to automate, And also it has possessed some soft skills in the sense that it should enable people to cooperate and act as a leader in a project. So that's why it's kind of a wizard for me. And then there is Jenkins. Jenkins is a well-known open source automation servers. It is composed of hundreds of plugins, and that's what makes Jenkins very, very powerful, the use of plugins. And Jenkins can cover the build, test, release, and deploy, and it has a control and agent architecture. So there is a Jenkins controller that acts as the controller, the master node for configuration, and then this controller is associated to many agent nodes. That's where the pipeline runs, the pipeline jobs run. And usually there is one controller and many agent VMs where pipelines are run in a continuous integration, continuous delivery way. So the current architecture is like this, and what I would like to do now is an exercise, and let's use this architecture and let's see how a DevOps engineer can deploy Jenkins for the teams. So let's say I'm the wizard, so Alberto is the wizard, and we have an initial team, an initial developer team, Team Star. Team Star is composed of 10 developers. They have to build an application with 20 microservices with Java 17. So what the wizard, that is the DevOps engineer, does is it gives them a Jenkins controller, also a Jenkins agent, and well, for the moment, they are happy. There is only one team. They have their Jenkins instance. They have the agent node, and they can deploy their microservices in a CICD way. So using Jenkins, everything is fine at this point of time. But let's see how it evolves. So let's say at a later time, there is another team, Team Alpha. So what happens is Team Alpha see that Team Star is being very productive using CICD and DevOps, and says, okay, I want some pipelines too. So what the DevOps engineer does here is, okay, use the same Jenkins controller that the other Team Star is using. I will add more agents VM, because now this Jenkins instance is used by 30 developers, so there are more builds run on the agents. The thing is, Team Alpha is using Java 8, so they are building microservices with Java 8, not Java 17. So the DevOps engineer will have to configure the Jenkins agent so that it can support both Java 8 and Java 17, and we'll have also to code the pipeline, to implement the pipeline for the new Team Alpha. It's becoming more complex, let's say. At a later time in T3, there is another team, let's call it Team Beta. So this team is composed of 5 developers. They have 7 microservices to build, and they use Go. The thing is, this team is fairly different than the other developer team, and they want a Jenkins instance on their own. So the wizard, let's say, instantiate a Jenkins controller and agent just for Team Beta, and also instance Go and all the SDK to build microservices in Go for the team. And in a later time, maybe there is a partner, and this partner also, they want to be completely independent. They have 20 developers, 25 microservices, and they code in Python. So the wizard will just instantiate another Jenkins with another Jenkins agent. So that is just to say that as times goes by, the Jenkins is not anymore scalable, and it's always hard to predict how much code will the team commit, and what if also the team grows or shrink, then you have to add or delete agent VMs. It becomes increasingly complex and very distributed. So from here, we can see some Jenkins challenges, and I've categorized them in 4 areas. One is scaling, management, standardize, and resource optimization. So the scaling part, as I say, the team growth. So it's difficult to foresee if a development team will grow or shrink. And also there is all the problem of scaling the agent nodes and estimating the agent nodes. There is problem with management because there are many Jenkins for every team, and the version updates are hard. I mean, if Jenkins version if the Jenkins version is updated, then the pipeline can break. Same for the plugins. And also, since many teams may use different programming languages, it's always difficult to configure the agents with the build tool and libraries necessary for building the application. There is also standardize, and standardize is something that a DevOps engineer will absolutely want, and also here during their work, during their job. Because if we standardize, then we can reuse. And that's also where we will explore configuration as code and also pipeline as code. If something is as code, then we can standardize and reuse the same code with different teams, within different teams. And there is also a resource optimization problem, since agent nodes are mostly underutilized, and there is a room for improvement with cost optimization. So how can we do this? How can we modernize Jenkins in a cloud native way? And here I want to start with some plugins, and I will tell you a set of useful plugins that can modernize Jenkins and solve some of these challenges. The first plugin we are going to see is the Kubernetes plugin. So this plugin enables the Jenkins controller and agents to be on a Kubernetes cluster. With this plugin, a developer team that wants to create a job pipeline, a job run, will contact the controller, and the controller will create a Kubernetes manifest, so a pod. That is, the agent as VMs are no more. The agent this time are pods instantiated inside Kubernetes. And these pods run only for the pipeline duration, and then when the pipeline ends, then the pod is destroyed. So that's a way to run dynamic agents using Jenkins. The pod is composed of many containers. So one container that is absolutely essential is the JNLP. This container will ensure the connection with the Jenkins controller. And inside the pod, there can be also many other containers. And that's why it's really useful, because the containers defined in the agent pod can be defined directly in the Jenkins file, in the pipeline definition. So the DevOps engineer needs only to specify the Maven version and the Maven container with a tag, and it will have it in the build runner that is in the agent. So if I have a team using Java 8 and a team using Java 17, I I just need to switch a tag of the container here to use, and that's very flexible in the in the pod. So it gives the developer, the DevOps engineer, a flexibility in choosing the build tools for the agents. So another plugin is the Jenkins configuration as code plugin. So we are provisioning many Jenkins. So we use the configuration as code plugin because we want to instantiate the Jenkins controller. We have seen that we instantiated many Jenkins controller, and the problem is that the Jenkins controller needs to be configured for every use. So if I give a Jenkins controller to team star and another Jenkins controller to team alpha, then I will, every time I instantiate a new Jenkins controller, I have to reconfigure all the configuration. With this plugin, it is possible to define the configuration as code. So it is possible to specify the configuration of Jenkins instances with code, that is with YAML. And this lets administrator setting up Jenkins only through YAML. And it is very, very useful to standardize the whole solution. So far we have seen the Kubernetes plugin and the configuration as code plugins, and only by using these two plugins, a lot can be solved. On the scaling side, if the team grows or shrink, I don't care anymore because the agent are created dynamically. So are created a spot in Kubernetes. And also there is no scaling the agent nodes anymore because the agent nodes are created dynamically as spot, and you can specify the resources in the pod manifest. Also, in terms of management, we don't need to set anymore the build tools on the agent VMs because we can specify the containers inside the pod, that is the agents, and also if you want to use another build tool, we just add a container or switch a tag in case we want to upgrade a build tool. And in terms of standardize, we have seen how to standardize the configurations through the configurations code plugin. That is, we define configuration as code so that we can reuse that configuration to instantiate many other Jenkins instances. The third plugin is the job DSL plugin. So this one is more related to a concept, and the concept is the seed pipeline. What is a seed pipeline? Basically, what a seed pipeline is a pipeline that generates other pipelines. Let's say I am team star and I have my own pipeline, but then I have to instantiate another Jenkins for team alpha, and when I instantiate the Jenkins controller, okay, it comes with all the configuration because we have used configuration as code. But then what about the pipelines for that team? They will have different requirements. What generally is done here is to have one seed pipeline per team and define all the pipeline as code. That is, that pipeline will generate other pipeline for the team. And that's how you standardize. And the code used to generate pipeline is called the DSL, the domain-specific language. And you can explore the syntax directly on your Jenkins instance by using your Jenkins installation URL. So using this custom URL. So with the job DSL plugin, we can create a seed pipeline. This is a pipeline that generates other pipeline for the teams. And that's how we can standardize always as code the pipeline. So if I have some pipeline that are reused across teams, I have them defined as code, and I just need to set them in the seed pipeline. The last plugin that we're going to see is the remote Jenkins file provider plugin. So here is more how to standardize the build, the build process, that is. And the Jenkins file is the file where the pipeline is defined. And it is usually in the source code repository, but with this plugin, you can externalize file. And this, from a DevOps engineer perspective, is very useful because I can standardize my entire build process. So if Team Star will need a Java pipeline, so a pipeline for creating a Java artifact, then the Jenkins controller will fetch the Jenkins file, that is the pipeline build definition, from an external repository like GitHub, and thus I have a standard pipeline for every team member. And if I need to update my pipeline, I just need to update the Jenkins file on this external repository, and the updated pipeline will get delivered to every developer. So with this plugin, we have standardized the build process. We can define pipeline as code and standardize the entire build process of Java microservices, Go microservices. I can define various pipeline as code. So I've put all together, and this is where the demonstration starts. What I've done here is using the official Helm chart to deploy Jenkins on Oracle Container Engine. And I've done it in a completely as code way, and also adopting some GitOps tools like Argo CD. It's very useful, Argo CD, because that's a graphical interface, so you can appreciate the whole Jenkins creation. And I'm going to show how this Jenkins, completely defined as code, is looking like. So let me pick up my demo environment here. So first of all, I have my Kubernetes cluster inside the Oracle Cloud Console. And yeah, this is my Kubernetes cluster. And inside this Kubernetes cluster, I have my node pools here. And the node pools are just a pool of nodes. It is a set of nodes that is logically divided in Kubernetes. I've deployed Argo CD inside this cluster. So Argo CD is a GitOps tool to configure and manage deployments on Kubernetes clusters. Inside Argo CD, I've this application that is Jenkins instances. So these Jenkins instances is completely defined as code, and it creates a secret and also an application, an Argo CD application. And it is an Helm chart that has other Jenkins instances as Helm charts. It's very better if I also see you the code here. So basically, Argo CD is connected to this repository. This repository is my repository in GitHub, and I have this Jenkins instance that is just a chart including all Jenkins instances on the cluster. So that's where the code is. And inside this chart that is connected in Argo CD, I have this subchart that is the team star. And this subchart is the Helm chart, Helm application for team star. So what happens here is that I create this Argo CD application here. I've created it, and using the Jenkins Helm chart, I've deployed Jenkins on OKE. So there are a couple of things worth noticing here. So this config map here is the configuration as code, and the configuration as code here is deployed as a config map. So that's how the Jenkins instance can get the configuration needed. And there is one that is the default one, and I've also defined one custom configs. So you can modify the Helm chart values and define your own configuration as code. You just need to go into the code here in the values. This is the Helm values. These are the values of the Helm chart. You can configure the Jenkins image to use. And also you can configure the configuration as code. That is here, config scripts, custom configs. And here you can define the configuration as code as YAML. You can also define in this Helm chart the plugins that the instance, that is the Jenkins instance, will have. So at the start of the pod, of the Jenkins pod, there will be an init container that is a container we run as an init container and install these plugins on the Jenkins instance. But the recommended way is actually to have your default Jenkins image with all the plugins, and you use it here instead of the one in Docker Hub. So we have also a view of what the Helm chart has created. So this is the load balancer that has created, and it exports to a service called of type load balancer, and it will go into the Jenkins instance pod. So if we go to this URL here, port 8080, here is my Jenkins. And that's the Jenkins that I've just instantiated.
Alberto, sorry for interrupting. Can you please increase a bit your screen size, because our customers are, I don't know, having difficulties seeing the code.
See
the code window. Yeah, it's perfect if you can do this.
Yeah, sure. So I will zoom. Yeah,
it's good.
Oh yeah.
Better.
Okay, I zoomed a bit.
Thank you, Alberto. It's fine now.
No problem. But yeah, basically these are just the value replacement for the official Helm chart. So it's good that you can configure it as code, and then I've deployed them through Argo CD. This is the Jenkins instance. I've put a message here, welcome to our CICD server. So this one is also configured as code. You can replace this message here. We can also manage Jenkins, since I'm an administrator. And this one happens always because I've not configured the Jenkins URL. but it's not a problem in this case. And this Jenkins instance is running as a pod here. So it is inside the Kubernetes cluster. We go to manage node and clouds, configure clouds, and that's where we can appreciate the Kubernetes plugin. So the power of the configuration as code is that everything comes already pre-configured. So even the Kubernetes connection to spawn the Jenkins agents, everything is already configured through code. It's very, very easy. So test connection, yeah, connected. You can define all the pod label, all the pod properties of the agents that the pipeline is going to build on. So this Jenkins has no instances, has no Jenkins agents, but it's only apparent because the agents are instantiated on demand. So I've created this pipeline through the job DSL plugin. Usually this pipeline is the seed pipeline, but here I've just connected one of my microservices here. So it's just a normal pipeline. And let's try to build it so that you can appreciate the Kubernetes plugin here. So what happens here is that I've obtained the Jenkins file from my remote repository, and the Kubernetes plugin that is comes already pre-configured to configuration as code is creating the pod on the Kubernetes machine, so on OKE. It will print the manifest of the pod generated and start running the pipeline on the pod that has created. So this pipeline will just build a Spring microservice. So generate a jar file and package it in a Docker container. So yeah, it's creating the Docker image. And as you can see, it's very quick. It only took, if we go to this build here and see the timings, yeah, about 1 minute, because pods are spawned really fast. The startup time is really fast. And you can also configure how much resources the pod will take on the cluster. Speaking of configuration as code, you can also see the configuration here. So you can view the configuration, and this configuration are taken from the Kubernetes config map. So you can see the configuration as code and you can reload it. What I would like here to do now is show the case where we have another team. So let's call team alpha here. So what I do here is just copy this folder, alpha, change the chart name, so it's not anymore team star, but it's team alpha. Jenkins and chart for team alpha. In the description, the version is okay. And as templates in the values, sorry, I just set the initial secret for the admin access. It was here. So it's not team star, it is team alpha. Okay, we are ready to commit here. So we just push the new code. Okay, it is pushed. And then we go into our Argo CD console here. So Jenkins instances, this one is the Helm chart enveloping all other Helm charts for Jenkins. Let's refresh it. Yeah, there is the new L chart, so the new Jenkins here, and the new secret that this one will be the admin password stored as a secret. So let's sync it. Okay, so the secret has been created, and also the new application, that is the Jenkins for Team Alpha. And let's go in the new application. So yeah, this is what these are all the objects that the Helm chart, the Jenkins Helm chart will create. And let's start syncing. So let's start creating the application. So as you can see, the persistent volume claim is being created, and also the service along with the pod. And the pod will first run an init container, installing all the plugins in the instance, and also it will be configured according to the configuration as code from the config map. We can see that we already have an IP address. It takes more or less 2 or 3 minutes to deploy it. In the meantime, I also wanted to go on with the presentation while we are waiting for Jenkins to be deployed, and talk about how we can optimize Jenkins cost. So the first thing is that the Jenkins controller can run on ARM instances. Actually, there is even a partnership between Oracle and Jenkins, so that the Jenkins images, Docker images, can run on the Ampere processors. And ARM instances are 25% less expensive compared to the general purpose instances. And the cool thing with OKE is that you can partition the node pool based on the different instances. So you can have one node pool for x86, one node pool for ARM with ARM instances, and one node pool for bare metal instances. But since Jenkins can run on ARM, the placement for our Jenkins pod ideally would be on the ARM node pool. And this is what happened with this is actually what's really happening. We've seen now the pod is on, and this pod, if we see here in the console, it is running on the ARM64 architecture. So it is running on an ARM node. And yes, you can configure the node selector and toleration and tails of the Helm chart so that the Jenkins controller is deployed on ARM. I have the node pool here. This one is my ARM node pool, and the Jenkins controller is perfectly running on this ARM instance. So this node is 25% less expensive, generally speaking. Another thing let's say for optimizing Jenkins costs here is using preemptible instances for agent pods. So preemptible instances are new to OKE, and you can define node groups using preemptible instances. And preemptible instances are just also called spot instances in other cloud provider, are instances that can be interruptible, that can be interrupted at any time, but they come at 50% lower cost. This means this is very, very useful for this use case, because the Jenkins agent pods running on the agent VMs are very short-lived. They last 2, 3, 5 minutes, and then they are deleted, and that makes preemptible instances optimal for this kind of workload. And this is also what's happening here, how I've set up here my Jenkins installation, that I've got my preemptible node pool here, and the Jenkins agent are spawned and run inside this the nodes in this node pool. So I'm saving a lot of money by having this Jenkins agents here. Yeah, so I have deployed the Team Alpha Jenkins here. So this one is another instance. It will have the same username and password. The other, it will come with exactly the same configuration as Team Jenkins, with the same pipeline. In a real scenario would be a seed pipeline, and I can build it, and it will share the this pod will be run in the preemptible node pool. So we create the pod, create the manifest, yeah, and run the pipeline. This makes everything more manageable, and yeah, it is a way to improve Jenkins and solving many problems with the overall Jenkins installation and management. But I always like to say almost everything can be solved, but unfortunately not everything. There are still some issues with this approach. So I've talked about version updates and plugins updates. If the Jenkins version is updated, or if a plugin is updated, it's not granted that the pipeline will continue to run. There might be some issues with the pipelines, and the only remedy for that, I would say, is testing. And since now we can reproduce another Jenkins installation very fast, then we can test it before actually upgrading the Jenkins for all the other teams. So yeah, that's the solution for the management part, testing. And then there is still the issue of some resource optimization, because yes, you can use preemptible instances, but those instances, they keep running on Kubernetes. Another way to optimize these instances is, like, if the developers are not using Jenkins, are not developing during the night, for example, you can easily scale the node pool to 0, and thus saving money. But what I'm hoping for the future, and this will happen at some point, is running this agent in a serverless Kubernetes serverless instance. And as the virtual nodes are improved, this will definitely be possible. And that's it for the demo. I hope that it has been useful for you, seeing this Jenkins how to approach and deploy as code. This with Cloud Native, and how we have solved like mostly everything that are Jenkins the Jenkins, I say, challenges. So over to you, Violetta.
So with that, I would like to end the call. Thank you and have a great day. Bye-bye. Bye.
Bye.